Good morning, students. Today we are going to discuss regarding congestion control. So congestion control means when the load on the network is greater than the capacity of the network, that leads to the congestion. So congestion, for example, I will give one general example regarding this congestion. So if the capacity of the room is 60, if the number of people enter into that particular room is 100, that leads to the congestion. Why? Because the capacity of the room, the number of people, the capacity of that particular room is only 60, but the number of people enter into that room is 100. That leads to the congestion. In the similar manner, in the network also, in the computer networks also, here if the load on the networks means the number of packets sent to the network is greater than the capacity of the network, that leads to the congestion. Now I will discuss congestion. Congestion in a network is nothing but the number of packets sent to the network is greater than the capacity of the network. The number of packets sent to the network is greater than the capacity of the network is called as a congestion. So that is nothing but the congestion. So now we have to control this particular congestion. Now we have to control this congestion. Now we will discuss how this congestion affects the delay as well as the throughput. Now I will discuss how this congestion, if congestion occurred, what about the how it affects the parameter delay as well as the throughput of a network. Delay as well as throughput are the two parameters, important parameters in measuring the network performance. Here, first I will discuss regarding how the congestion affects on delay. For example, here in the x-axis I will take load, in the y-axis I will take delay. So initially the load on the network is less, the delay is also less. Whenever the load on the network is increasing, the delay of the network is also increasing. It is exponentially increasing. At one particular instant of time, it is going to be increasing abnormally. That is not shown. Whenever the load on the network is greater than the capacity of the network, which the delay is going to be abruptly increasing. So now here in another case, here we will take here how this congestion affects the throughput of the network. Here in the x-axis let us take load, in the y-axis let us take throughput. Here initially the load on the network, here the throughput of the network is very less. Why? Because the load on the network means the number of packets sent to the network is less. Initially at one particular point it is very high. After reaching this particular point, the throughput of the network is going to be gradually decreased. So this is nothing but how this congestion is going to be affects the throughput. Throughput means the number of packets sent to the network in a unit interval of time. It is similar to the bit rate, but in bit rate we will consider only number of bits per second, but in the throughput we will consider here the number of packets sent in a unit interval of time. So this is called as number of packets sent to the network. Number of packets sent to the network in a unit interval of time. So this is how the congestion affects the delay as well as the throughput. Now here, how to control this congestion? There are different techniques There are different techniques to prevent this congestion techniques. Okay. Prevention is better than cure. So we can control this congestion by using some prevention techniques that are closed loop, open loop congestion control technique. Another one is a closed loop congestion control technique. So in first here the congestion control techniques are divided into two broad categories. One is open loop congestion control, another one is closed loop congestion control. One in open loop congestion control we have retransmission, window policy, acknowledgement policy, discarding policy, admission policy. These policies comes under open loop congestion control technique. Open loop means there is no feedback from output to the input. So this is called as a open loop congestion control technique. There is no feedback from output to the, that means there is no feedback from the receiver to the sender. So this is called as a open loop congestion control technique. Next, another one is the closed loop congestion control technique. In closed loop congestion control technique, there is a feedback from output to the input. So that's what this is called as a closed loop congestion control techniques. In closed loop congestion control technique, we have back pressure, choke packet, implicit signaling, explicit signaling. Okay. Now I will discuss regarding retransmission policy. In retransmission policy, we should have one efficient retransmission policy for to avoid the congestion. When we are going to retransmit the signal, whenever there is a congestion is occurred, whenever the error is occurred, we have to retransmit that particular packet. This retransmission packet should be in efficient manner. We have to retransmit the packets. Those who are affected, that packets only retransmitted. If I am going to send unnecessarily retransmit the packet, that also leads to the congestion. So this is the retransmission policy. So this is also, so we have to use one effective or efficient retransmission policy. Now another one is a window policy. In window policy, we have to use different windows. Windows means go back and stop and wait ARQ. There are different window techniques are there. As we have discussed in the earlier classes in error control techniques. So we have to use efficient window policy mechanism for controlling the congestion. Now acknowledgement policy. Normally we have to acknowledgement the packets. This acknowledgement that should be instead of individually acknowledge the packets, we have to acknowledge the packets in group wise. So that also avoids the congestion. So for that we need efficient acknowledgement policy. Next, another one is the discarding policy. We have to use one efficient data. We have to discard the unnecessary data. We have to discard unnecessary data. So that is also avoids the congestion. Now another one is the admission policy. Admission policy means we have to admit the packets which are necessary. Which are not necessary, we have to just discard that particular packets. So these are the different open loop congestion control techniques. Now regarding closed loop congestion control, we have back pressure, choke packet, implicit signaling, explicit signaling. So first in this I will explain this choke back pressure method in diagram. So in this one there is a source node, here we have destination node. For example, here in the third node, here the congestion is occurred. That means the load on that particular node, it is observed that the load on that particular node is greater than the capacity of that particular node. Then this node gives that particular special signal to the particular node 2. This particular node 2 gives the signal to the node 1. This node 1 gives the indication to the node particular source node. So from this, the source node understands that the congestion is occurred. So that's why here the source node sends the packet slowly. The source node sends the packet slowly. In this way also we can avoid the congestion. So this is one of the best technique for congestion control. Next, another technique is here choke packet. In this choke packet method, instead of here where in this particular one, that is the same third node affected with the congestion. But in this particular case, here this particular third node does not give the signal back to the node 2. It gives the signal to the directly, gives one special packet to the directly to the source node. It does not give the signal to the 2. This 2 node does not carry that particular signal to the 1. But in this particular case, here this particular node 3 directly gives one particular packet or to the source node. So this way we can avoid the congestion. So in this way we can work efficiently. We can efficiently avoid the congestion compared to the previous method. So that is one technique for choke packet. Next, another techniques are choke. Next, another one is implicit signaling, another one is explicit signaling. These are implicit signal means the node itself, it understands that some congestion is occurred. The node itself understands that the congestion is occurred implicitly. So it can reduce the number of packets sent to the node. It's a node. Gives the nodes is given indication by other nodes. So these are the different open loop congestion control techniques, closed loop congestion control techniques. Now in this class we have discussed congestion. What is meant by congestion? What are the different congestion control techniques? Now I will ask two questions that are for you. One is, what is mean by congestion? Then what are the different congestion control techniques? These are the regarding this class.